the number of photons falling per second on a completely darkened plate to produce a force of 6.62 into 10 to the power minus 5 Newton is n. That is number of photons falling. If the wavelength of the light falling is 5 into 10 to the power minus 7 meter, then n is equal to the value you have to find out into 10 to the power 22. So, power we have to see, because number of photons, see, each photon produces energy which is equal to h into nu, where h is Planck's constant and nu is frequency of its radiation. However, we know nu is equal to, C is equal to nu lambda. So, lambda can be written as C by nu, correct? C by nu it can be written. Okay, lambda is C by nu. So, energy also becomes, or else nu I can write. I have to substitute nu, right? So, that will become C by lambda. So, it is Hc by lambda. This is the energy produced by each photon. So, for each photon, power by normal definition is energy per unit time, work done per unit time, energy per unit time is power, correct? So, that can be for n number of photons, power produced is, this is for each photon, this is a total power total is n, that is number of photons into power produced by each photon, that is the equation. Now, P total is n into wavelength is given, so that is Hc by lambda into T. Now, power is also force into velocity. So, we also know in first year you have studied, power is force into velocity for photon which travels with the velocity not v. This is for any other material, it travels with the velocity v, whereas light particle travels with the velocity c, correct? So, power can be written as F into C. So, combining equations 1 and 2, what I am going to write is Fc is total power for a photon produced by the photon, and with respect to its wavelength, this is the equation, n into Hc by lambda T. So, C and C cancels. Now, you want n, right? So, that is F lambda T by H is n, which is equal to, if I substitute the values, F given as 6.62 into 10 to the power minus 5 Newton, this is what they have given. Lambda is 5 into 10 to the power minus 7. Time is of course 1 second, that is 1 second. H value is 6.62 into 10 to the power minus 34. Now what happens? 6.62 cancels. What remains? N is equal to 10 to the 5 into 10 to the power minus 12 into 10 to the power 34. This comes to the numerator. So, number of photons falling per second is this much. 5 into 10 to the power 22. But they have asked you to find out this integer. This is already given to you. They have asked you to find the integer, which is a multiplier of 10 to the power 22 and its value is 5. So, option B is the correct answer. Option B is the correct answer.